Assalamualaikum warahmatullahi wabarakatuh. My name is Shami and I will be presenting the first part of our problem. So first we must find the Cartesian equation by substituting the z naught equals to 4 plus 4i, radius equals to 2 and z equals to x plus yi. So from here we can get the Cartesian equation to be x minus 4 squared plus y minus 4 squared equal to 2 squared and conclude that the center is 4 for a radius of 2. From this info we can find the equation of line passing through the origin and the center by first finding the gradient. So we got the gradient equals to 1 and substitute this value into the y equals to mx plus c to get y equals to x. So we can visualize what our graph is going to look like and find that there's 2 points which is the closest and the furthest from the origin. To find the coordinates, we must use the simultaneous equation method by substituting y equals to x into the Cartesian equation. So from here, we got x equals to 4 plus z2, 4 plus minus z2. And since y equals to x, we directly got the value of y also. So from here, we can see that we got the formula for the z min and the z max. Moving on, we must prove the formula z min equals to z naught minus r times z naught over the magnitude of z naught. First, we must find the magnitude of z naught, which is 4 z2. And from here, we can use simplification and simple rationalization to find that the coordinates we got from this formula is the same as the one we got from the simultaneous equation. Hence, we prove that this formula is actually true. So this is our my calculation. Thank you.
For the modulus extrema, we know that our circle equation is x minus 4 square plus y minus 4 square equals to 2 square. And when we sketch the graph, we know that the center is at 4, and the line that passes through the origin and the center of the circle is defined by y equals to x. Okay. When we substitute y equals to x into our circle equation, we will get our x to be 4 minus z2 and 4 plus z2. Since we said that our y is equals to x, so our y1 is also 4 minus z2 and 4 plus z2. From this, we know that our z minimum is 4 minus z2 plus 4 minus z2i, and our z maximum is 4 plus z2 plus 4 plus z2i. Okay. And now, in order for us to find the modulus z minimum and the modulus z maximum, we need to know the modulus of z naught first. So the modulus of our z naught is 4 z2. Our z minimum, we can calculate it directly by using the formula z modulus minimum equals to z naught minus r, and we get 4 z2 minus 2. And our z max, we just need to plus r to our modulus of z naught, and we get 4 z2 plus 2. Okay. If we try to prove this by using the equation, just substitute the value into this formula, and then you will get z minimum to be 4 minus z2 and 4 minus z2 plus 4 minus z2i, which is which is the same from the previous one. And then the same goes to z maximum. We substitute the known value into this equation, and then we will get our z maximum to be 4 plus z2 plus 4 plus z2i. For argument extrema, with the locus, we make two tangent line here, and then we will know our z minimum, our smallest z argument, and our maximum z argument. Okay. If we substitute the gradient line y equals to mx into our circle equation, we will get 1 plus m square x square plus x plus negative m minus 8m x plus 28. And then we know that this line is the tangent of the circle, so it touches only at one point. So our discriminant must be set into 0. Okay. After that, we find the value of m, and we will get m equals to 8 plus minus 28 over 6. Okay. Since we know that gradient is equal to tan theta, so we just substitute our value of m to find the argument z minimum and argument z maximum. So we will get our theta minimum to be 24.3 and theta maximum to be 65.7.
Okay, now for my part, I will be talking about the ellipse equation. I chose a horizontal ellipse with a z1 of negative 3 plus 2i and z2 of 5 plus 2i and a of 10. So, to start with, we first have to sub in the values, of course, and then we have to expand it by isolating and squaring both 2 times to get this value here. 9x squared minus 18x plus 25y squared minus 100y minus 116. And then we have to complete the square twice. We got to get this equation, 9x minus 1 squared minus 9 plus 25y minus 3 squared minus 125, and then separate the ones with variables and without, and then divide it by 9 and 25 to get this ellipse equation. And then we get the center 1, 2, major axis 5, minor axis of 3, and the foci of negative 3, 2, and 5, 2. Okay, that will be all for me.
For ellipse, for modulus extrema for ellipse, recall that our ellipse equation is this. So when we differentiate our ellipse equation, we will get dy dx to be negative 9 minus x 9 x minus 1 over 25 y minus 2. This equation is the gradient tangent of the ellipse. Okay. Now this is when we differentiate the distance, we will get differentiate of d, we will get 2x plus 2y dy dx. Since we know that differentiate of dd over dx is 0, so we got our third equation. Okay, and then from the third equation, substitute the second equation into the third equation, and then we will get y to be 50x over 16x plus 9. Okay, this will be our fourth equation. Okay, so we substitute back our fourth equation into our first equation to get our x maximum and x minimum. Okay, after we do the expansion, we will get our x maximum to be 5.8 and our x minimum to be negative 0.13. Okay, so when x maximum to be 5.8, we just substitute the following value into our ellipse equation, and then we will get y to be 2.85. Okay, and then for the y minimum, we substitute the value of x minimum into the equation, and then we will get y to be negative 0.92. we know that our Z maximum is 5.8 plus 2.85i, and then the modular Z maximum is 6.46. For the modular Z minimum, we will get 0.93. For argument extrema, we substitute the equation y equals mx into our ellipse equation, and then we will get our and then this will be our final equation. Okay, when we set our discriminant to be 0, we will get the value of n to be -4 plus minus negative 464 over 48. Okay, we know that our discriminant is already give our value a negative value, so there is no real value of m that makes the line tangent, and only complex values of m that satisfy the discriminant, which is b squared minus 4ac equals to 0.
Now let's visualize the circle. The P1 is a Z minimum with this coordinate, and P2 is a Z maximum with this coordinate. There are two tangent lines that pass through the origin. For this line, the intersection point is A with this coordinate, and this tangent with the intersection point of B with this coordinate. The minimum argument is 0.424 radian, and the maximum argument is 1.147 radian. Now let's visualize the ellipse. The sum of the length of the h and I is also equal to the major diameter, which is 10 units. So the P1 is a Z minimum with this coordinate, and the P2 is a Z maximum with this coordinate. There is no real gradient that satisfies tendency because origin is below the ellipse.
To wrap up, our manual proofs completely aligns with our GeoGebra model. For the circle, our Cartesian equation and extrema for modulus and argument, including our 24.3 and 65.7 degree tangents, were visually validated by the software's tangent rate. For the ellipse, our manually calculated Zmax of 6.46 matches with the software's 6.4589, with any minor differences being simple rounding. Most importantly, we have confirmed why no real tangent exists for the ellipse. Our discriminant was negative because the origin lies inside the locus.